Good morning, all. Uh, can you see my screen?
Yes, sir.
Yes, sir.
Okay. Okay. In last lecture, we have completed up to this point the process representation in Linux operating system. By defining the structure, we can uh, declare any kind of a process. Okay, which consists the different parts of the processes, and we have completed up to this slide. Okay. Then we'll move to the next point, and that is nothing but the process scheduling, how we are going to schedule the any kind of a process. Then in this we'll summarize first of all some kind of a thing that is the part of the processes. Then okay, this is nothing but the PCB. For every process we need to define the PCB. Operating system is going to define the PCB for every process, and then if there is a switching between the processes, how it is going to be switched one. So that is nothing but the this is the diagram we have discussed in yesterday's lecture. Then we have seen the some concept of the threads also. Then how we are going to represent the process in the Linux, okay, that we have also seen in the last lecture. Okay, now it is about the process scheduling, how the processes are going to be scheduled. Okay, which mechanism is used to schedule the process, that we have to understood. So first of all, in the multi-programming system, it is the basic need to schedule all the process. When we want to run all the processes at multiple process at the same time, then there is a need of the process scheduling. Otherwise, if there is a in batch system, we are going to run the only one process at a time, then there is a no such need of a process scheduling. But when we are thinking about the multiple process we need to run at the same time, then there is a need of the process scheduling. Then there is a how the operating system is going to schedule the process. If there are the thousand of processes are present in the CPU at the same time, then how it is going, then how OS is going to be work, that we need to understand into the process scheduling. Okay, then about the first point, maximum the CPU use and quickly switch process onto CPU for time sharing. Okay, when there is a time sharing operating system is there, then there is a need of the switching the processes frequently, and then how that scheduling is done we need to understand. The next point is about the process scheduler selects. Okay, so there is a one process scheduler is in your
Hello.
system.
Hello,
Hello.
sir. Hello, sir.
Hello. Hello. Okay, everyone can hear my voice.
Yes, sir.
Okay.
Yes, sir.
Then process scheduler.
Yes,
Okay,
sir.
in the system, okay, the process scheduler is going to be there to schedule the all the things. Then this process scheduler selects among available process for next execution of the CPU. Means suppose there is a one process is in executing mode, then which process next we are going to select it, that is decided by the process scheduler. So what is the task of the process scheduler? The scheduler selects among the available processes which is in a ready state, and that we need to execute in the further moment when the executing process is going to be complete. So the what is the task of the process scheduler? The process scheduler select the process and it is going to be executed next. So that is the task of the scheduler. Then how the scheduling queues of the processes. So there are the different kind of the queues are maintained for scheduling of the process. Okay, we know what is the mean of the stack, what is the mean of the queues. What is mean by the queue? The queue is nothing but the there is a first in first out. Okay, if there one process comes, then that process is going to be completed, and this is the simple FIFO structure is there. Okay, we have the understanding of the queue in the basics of the data structure. So there are the different types of the queues are maintained in the operating system. So that which different kinds of the queues are maintained. The first one is the job queue, the next one as a ready queue, and then next one as a device queue. So these all the having its importance and their functions to work. Okay, just a minute. जरा फॅन वाढव ग. एक ना फॅन वाढव जरा गरम आले बघ. Okay, so these are the three types of the queues are maintained in the process scheduling, and that this is maintained by the process scheduler. So what contains the job queues? The job queue contains the set of all processes in the system. Okay, means whichever the processes are in the system, that is contained in the job queue. So next one, what is in the ready queue? Okay, those are ready state, and all the resources are acquired by that process. So these all the processes are we need to put it into the ready queue. Then what is in the device queues? So set of process waiting for the IO devices. Those processes are waiting for the devices, means input output devices. And those are the ready with the CPU, but these are waiting for the IO devices to execute. So these kind of processes are put into the device queue, and processes migrate among the various queues. Okay, so it can be happen that when one process P1 is in the device queue, later that the CPU is available, also IO is available, then that process P1 process is put into the ready queue and ready for the execute. So what is the meaning of the processes migrate among the various queues is nothing but the if there are the certain dependency, and then that dependency is going to be complete, then that process is going to be put into the that particular queue. Okay, so in this slide what we understood, one of the process scheduler is there to select among the processes which process next we want to execute on CPU. Okay, that is the task of the process scheduler. Then there are the different scheduling queues are maintained in the operating system, just like a job queue, ready queue, and the device queue. Simply what the job queue contains, the job queue contains the set of all processes. Okay, what job queue contains, the set of all the processes having in the system. What the ready queue contains, the set of all processes residing in the main memory and ready and waiting to execute, means which processes are acquired all the IO devices, then it is having the CPU also, and these all the processes are contained into the ready queue. Then next one as a device queues. Then device queue, what is mean of the device queue? It is it contains the set of process waiting for the IO devices. Means all the processes those are ready in state but waiting for the IO devices. Okay, and processes can migrate from the one queue to the another queue. Why? Because for example, we can take the process one is having the CPU but waiting for the IO device. Okay, when the IO device is with the process P1, that we need to put it into the ready queue. Okay, so this is the thing about this slide, and then we will move to the next one. That is the in this diagram, the ready queue and the various IO devices queue is going to be present here. Okay, we will see what is the meaning of this diagram. Okay, here in the first of all, this is the simply link list structure. Okay, in the data structure we have seen these all the types of the data structure: stack, queue, linked list, and these all the data structure are used in the operating system structure. Okay, this is the named this is as the ready queue. This is the queue for the magnetic tape. This is the another queue for the magnetic tape. This is the disk unit, and this is the terminal unit queue. Okay, so these all types of the queues are maintained in the operating system to handle the different processes, and those processes are waiting in the ready queue. These are the simply created by the, this is the linked list. Okay, this is the simple structure as a linked list. Okay, whereas the first one is having the link to the uh, first one, then it is having the link to the another one up to the end. Okay, and this is the simple structure, this is the head and this is the tail. Okay, the tail points to the last process and the head points to the first process. Okay, and for every process we know that there is a PCB, process control block is there. Okay, and which contains the different fields. So we can think that when we are working with the data structure, we can simply create the linked list structure. Okay, and for every queue there is a linked list structure is created. So this is the simple meaning of the this diagram. Okay, hopefully this diagram is clear to all of you. For every queue there is a linked list structure is created. Okay, this is the simply pointers head and tail. Head points to the first process, tail points to the last process. Okay, and this is the interconnection between the processes. Okay, if there is a sorry. Okay, for every process we need to create the PCB. Okay, and then there are the different queues are maintained, and that is shown. Again we can take the example of the disk unit Q0. This is the head pointing to the PCB3, then link to the PCB14, PCB6 up to, and tail points to the PCB6. So this is for the diagram of the process scheduling. Okay, in the process scheduling, what we understood, one process scheduler is there to select among the available process next to execute. There are the different queues are maintained to execute the process. For example, job queue, ready queue and device queue. Process migrate from among these queues, means if device is not available, that process is going to be put into the device queue. When device is available, we need to put it into the ready queue. So this is nothing but the migration, means transmission of the process from one queue to another queue. um, okay, and this is about the diagram how the queues are going to be maintained into the operating system. The next queue is about the representation of the process scheduling. Okay, here the two queues are going to be shown here, represent the queues, resources and flows. When any one of the process is going to be created, okay, when new process is going to be came here, new one, simply it is going to be put into the ready queue if it is having the all the resources, and it is going to be executed by the CPU and it is going to be terminated. Okay, but in meanwhile the some IO request comes, means that process, new process, we can say it is a P1, but the P1 requires the input output. Okay, if it requires the input output, it is going to be put into the IO queue. It is going to be put into the input output queue. When it acquires the input output, then again it is going to be put into the ready queue. Okay, then what is mean by the time slice expired? Suppose we are using the round robin algorithm. That is the round robin algorithm, means we are using the time sharing system. Okay, so for we know that for the time sharing system, every process is having the some time slice. Means suppose for every process we are allocating the 1 second, then process P1 is going to be executed for the 1 second, and when its time slice is going to be expired, then again it is going to be put into the ready queue. And when the again its term come, then again it is going to be go for the execution. Then next one, when suppose in the P1 process, we are using the fork system call. Fork, F-O-R-K, fork system call. Okay, what fork system call does is nothing but the creating the child processes. It may happen that the one parent process can create the many child processes. Okay, and in that case, when P1 creates the child process, then the parent process must wait for the child execution. So the parent process is goes into the waiting state, and the when the child executes it, again it comes for the ready queue to execute. That is the condition again. So this is the condition number 1, this is the condition number 2, this is the condition number 3. Then what is the condition number 4? The condition number 4 is that when any kind of an interrupt occurs, just like a higher priority process comes, then that interrupt is going to be completed first, and again your process is going to be put into the ready queue. So these are the 4 conditions how the flow of the process or the how the queue can be handled and which kind of consequences can come when any kind of a process is going to be executed. So there are the maybe that there may be a different kind of a another consequences is there, but in for the study purpose we are going to consider these 4 conditions how the queue is going to be handled when the process scheduling is done. Okay, I will repeat it again. When the process P1 is going to be come here, okay, we know that the process newly process P1 is going to become, it is simply put into the ready queue. If it is acquired the CPU, if it is having the IO with it, it is going to be executed and going to be out from the CPU. But in between it requests for the IO, then it is going to put into the IO queue. When the IO is available, again it goes for the radio, then CPU is allocated and it is going to be out. When we are using the round robin algorithm or the time sharing system, then time slice is going to be assigned for the every process. When process P1's slice expired, then again it is going to be stop, and when it is going to be again put to the ready queue, and when again the time slice come for that P1 process execution, it is going to be executed and out of the CPU. Then another condition is that when the process P1 has the fork using the fork system call in its process for the creating the child process, it may happen that the parent process can call the many of the childs. Then the first of all the parent must wait for the child execution, and when the child process is going to be executed, then the parent process is going to be again put into the ready queue and it is going to be executed and out from the CPU. Then another condition is that it is waiting for the interrupt. When interrupt occurs, then it is going to be stopped, and when interrupt is going to be completed, again it is going to be put into the ready queue. Otherwise, we can take the example of the pressing the keyboard key as an interrupt. When I press the keyboard key as a up to pressing the key there is nothing is going to be happen. We are not going to see any kind of a input on our monitor. But at the same time, when we are pressing the keyboard key A, then A is going to be printed on your monitor. So this is nothing but the waiting for the interrupt. And when interrupt occurs, then it is going to be put into the ready queue and it is going to be executed and out from the CPU. So this is the simple meaning of this diagram, and it is the representation of the process scheduling. I think this is going to be clear to all of you. Then next point as a scheduler. So we know up to now we know that how the process scheduler is there for scheduling the all the processes. We know that there is a queue is maintained for um, doing the process scheduling. Which kind of a queue is maintained? There is a job queue, then ready queue, and then IO device queue is nothing but the IO queue. Okay, so these kind of a queues are maintained, and there is a switching between the processes from these queues also. Okay, then next we will go for the understanding of the schedulers. So there are the two different types of the schedulers are used into the operating system. Is first one as a short term scheduler and the another one as a long term scheduler. So meaning is very easy for the short term scheduler and the long term scheduler. Okay, we'll see first of all the short term scheduler. The short term scheduler selects which process should be executed next and allocates the CPU. Okay, what is the task of the short term scheduler is nothing but the select which process should be executed next and allocate the CPU. Sometimes the only scheduler in the system, in some kind of a system this is the only kind of a scheduler. There is a no long term scheduler present in the uh, many of the systems. Then next point, the short term scheduler is invoked frequently in millisecond, must be fast. Okay, what is the um, when the short term scheduler is invoked, it is going to be invoked, it is going to be invoked frequently in the millisecond. Okay, now we will see the long term scheduler and then we will compare it with the short term scheduler. Select which processes should be brought into ready queue. Okay, which process we need to bring it into the ready queue, that is decided by the long term scheduler. And what the short term scheduler decides, the short term scheduler decides which process is going to be executable in the next and allocates the CPU. That is decided by the short term scheduler. And what long term scheduler decides, the long term scheduler decides which processes we need to bring it into the ready queue. So that is the basic difference between the short term scheduler and the long term scheduler. Then next point, long term scheduler is invoked infrequently. There is a no need to invoke it just like frequently in a millisecond, just like in a second or minutes we can invoke it. Then the long term scheduler controls the degree of multi-programming. So long term scheduler is responsible for creating the multi-programming environment, means mixing of the all processes, that is done by the long term scheduler. So there is a, what is the basic difference between the long term scheduler and short term scheduler is that the short term scheduler is responsible for which process is going to be executed next and allocates the CPU, whereas long term scheduler is responsible for which process we need to brought it into the ready queue. This is the first difference. What is the next difference? The next difference is about the short term scheduler. As the name suggests, it is going to be executed frequently in milliseconds, whereas long term scheduler, it is going to be invoked infrequently in a seconds or the minutes. Okay, it is a short term scheduler is a fast, the long term scheduler is a slow, we can say that. Then what is the fourth difference? It is long term scheduler is responsible for multi-programming, whereas short term scheduler is responsible for the execution of the process. Then next one, sometimes short term scheduler are present into the system, only scheduler present into the system, whereas long term scheduler may present or may not present, depend on that system. So these are the some basic differences I have shown you, that is in the difference between the short term scheduler and the long term scheduler. The long term scheduler can also called as a job scheduler, and the short term scheduler is also called as a CPU scheduler. So these are the basic 6 differences between the short term scheduler and the long term scheduler that I have described you. Okay, uh, so we'll go to the next point. Processes can be described as either IO bound process or the CPU bound process. So this is the very basic definition for the IO bound and the CPU bound processes. When the it spends more time doing the IO than the computation, if we can simply consider that the one of the process P1 is executing or spends more time on the IO computation, then it becomes a IO bound process. And when one of the process spends more time doing the computation, then it becomes a CPU bound. Okay, what is meant by the IO bound and CPU bound? It is a very easy one. when one of the process spends more time on the IO computation, then it becomes a IO bound. When it spends more time on the CPU computation, doing the some computations using the CPU burst, means using the maximum time CPU, then it becomes a CPU bound process. Okay, the long term scheduler strives for a good process mix. Okay, we know that that is in this point is clear into the degree of multiprogramming. Okay, so the good process mix is done by the long term scheduler. Okay, moving to the next point, addition of the medium term scheduling. Okay, so in many of the operating system, medium term scheduler is going to be used. Okay, we have seen the short term scheduler and the long term scheduler. Okay, the short term scheduler is also called as a CPU scheduler, and the long term scheduler is also called as a task scheduler. Okay, whereas the medium term scheduler, what it means. Okay, we have seen in the chapter 2 concept of the swapping. Okay, removes the processes from the memory store on the disk, bring back in from disk to continue its execution. It is called as a swapping, and when the swapping is going to be used in the system, that becomes a medium term scheduler. Okay, so in this diagram, the swap in and swap out process is going to be shown here. Okay, the process is in the ready queue, but we know that it is going to be swapped out. Okay, it is in the ready state, but it is going to swap it out because of the some process we need to execute. So this is the virtual memory of your machine. Then when the again you have the space in the ready queue, then again we can move it to the swap in for the that process we need to execute. And when any kind of a process is waiting for the IO, then it is going to be put into the IO queues, and when the IO is available, again put it into the ready queue, and when the process is going to be executed, it is going to be end. Okay, so this is the meaning of this diagram. What is mean by the medium term scheduler? When there is a use of the swapping is done in the operating system, then that is the medium term scheduler is going to be used in that system. Then we'll go to the context switch point. Okay, so in the diagram of the process switching, we know that there is the switching between the process. So when the CPU switch to another process, it must save the state. Okay, how we are going to save the state? In the PCB, we are going to save the state into the PCB, and when of the old process and load the saved state. Okay, where we get the saved state? Into the PCB for the new process via context switch. So what is mean by the context switch is nothing but the we can refer the process switching diagram again here. That is nothing but the when we are going to switch between the process, then state of that process is going to be saved into the PCB, and when it is going to be revoked again, then again we have to load that state and we are going to execute it. Okay, the next point is about the context switch is time overhead. So you can tell me about why it is going to be overhead. We need to executing one process, and in between we are going to stop it, and again we are going to load the another process, and again we are going to execute that process. So that is nothing but the switching overhead. Means many of the times we are going to switching between the process, and that time is compromised by the CPU. So this is nothing but the context switch time is nothing but the overhead. The more complex OS and the PCB, the longer the context switch. Okay, the many of the times the context switch is a longer, it will require the more CPU time. Then time dependent on the hardware support. Okay, means what kind of hardware your operating system is going to be used, so that the hardware dependency is also there on the context used for the context switching. So this is the last point for today's lecture. Okay, in next lecture we will go to see the different operations on the processes. Okay, if you have any kind of a doubt, Okay, you can go ahead and ask for the doubt.